Hello everyone. Today we're going to be talking about compressions, expansions, and reflections for graphs, whether it be a graph that is actually a function or whether it's something that we kind of make up and go with, doesn't really matter. This is based on what we learned last year with the vertical stretches and squishes and the translations right, left, and up, down. And we're adding on one new piece this year, the horizontal expansions and compressions and reflections. Let's take a look. So in general, we've seen it before, y equals a f of. We've seen the x minus c and the plus d. The b is new. The a, as last year, vertical expansion, compression, reflection, everything up and down. The c works opposite the sign, so if it says -3, we're actually moving right 3. And in the same way, the b value is the reciprocal of the b value. We talked about this the other day in trigonometry. So if it's a number 2, it actually means a half. If it's a number a third, it actually means a 3. So let's take a quick look at some examples. I had some stuff and now I'm just moving it around. Suppose f of x is as drawn. We're going to get a lot of this. So in this particular case here, I've got 5 points. Kind of makes the letter m, I suppose. That's my f of x. What we want to graph is g of x, which is equal to a -2, f of 3x. The -2 is going to stretch it vertically by a factor of 2 and flip it upside down. The number 3, the b value, is going to do something different. So the a value, I've just drawn it on the screen. It should make sense to you. The 3 is going to turn into a third and compress the graph horizontally inwards towards the y-axis. All of my x values I'm compressing inwards by a third. I end up with a very squished graph. I'm just redrawing it in purple because it wasn't easy to see in pink. There's also something called mapping notation that helps us with this. If I take my original points, x, y, I'll notice that my x value got compressed by a third. My y value was technically multiplied by a -2. So what I can do then is I can actually take the 5 points that I started with and to each one of them apply this mapping notation. It ends up giving me the following points. So I'm literally just multiplying the original x by a third, the original y by a -2. And I end up with all 5 of the dots that I had on my purple curve that I drew up just above. I think it's hidden by my face right now. In general, for mapping notation, the x becomes a 1 over b minus c, and the y becomes an ay plus a d. Let's look at another example. Suppose f of x this time looks kind of like a half circle followed by an arrow going upwards. And we want to graph g of x, which is equal to a negative f of 1/2 x, where the 1/2 is going to, that's right, stretch horizontally by a factor of 2. The b value always flips. The negative in the front is just going to do what it's always done. It's going to flip my graph upside down. So in my mapping notation, the 1/2 turns into a 2 times x. The negative just stays as a negative. I calculate that to all of my points, and then I go graph them. It looks like it's been stretched, flipped. I think that's good enough. We got some homework. It's on page 28. Could you please try number 3 and 5 odd letters, number 6, 7, 9, and 14. That's it for today. Enjoy.